Hello everyone, I am Dr. S. Madan Kumar, Erode Engineering College, Department of Chemistry. I go to the Engineering Chemistry of Unit 4, Polymer Chemistry. First of all, Introduction, Monomers, Polymer, Polymerization, Functionality, Degree of Polymerization, Classifications of based on Source and Application. Introduction. The word polymer is derived from Greek words poly. Poly means many and mer means unit or part. Polymers are generally macromolecules formed by the repeated linking of large number of small molecules. Polymers are widely used in automobiles, defense, electrical goods and computer components, etc. Define polymers. Polymers are macromolecules that's called gain molecule of higher molecular weight formed by the repeated linking large number of small molecules called monomers. Example, ethylene reacted to form polyethylene. Polyethylene is a polymer formed by the repeated linking of large number of ethylene molecule. Define monomer. Monomer is a micromolecule that is called small molecule which combines with each other to form a polymer. Some monomers and repeating unit of the polymers are given below. Examples, ethylene, propylene, vinyl chloride, styrene, acrylonitrile, vinyl acetate. This is all the important monomers. Repeating unit of polymer, ethylene, polyethylene, propylene, polypropylene, vinyl chloride, polyvinyl chloride, styrene, polystyrene, acrylonitrile, polyacrylonitrile, vinyl acetate, polyvinyl acetate, acrylic acid, polyacrylic acid, methyl acrylate, polymethyl acrylate, methyl methacrylate, polymethyl methacrylate, tetrafluoroethylene, polytetrafluoroethylene, butadiene, polybutadiene, isoprene, polyisoprene, chloropyrene, polychloropyrene, ethylene terethaplate, polyethylene terethaplate, 5-phenyl epoxy resin, hexamethylene diamine, nylon 6,6. Carprolactam nylon 6, alpha amino antionic acid nylon 11. This is one of the monomer and repeating unit of the polymer of examples. Define polymerization. Polymerization is a process in which large number of small molecules called monomers combine to give a big molecule called a polymer with or without eliminations of small molecules like water. Define degree of polymerization dP. The number of repeating units n in a polymer chain is known as degree of polymerization. It is represented by the following relationship. Degree of polymerization equaled molecular weight of the polymerization network divided by molecular weight of the repeating unit. In this example, 5 repeating units are present in the polymer chain. So, the degree of polymerization is 5. Polymers with low degree of polymerization are known as oligomers. Their molecular weight ranges from 500 to 5000. High polymers. Polymers are high degree of polymerization are known as high polymers. Their molecular weight ranges from 10,000 to 2 lakhs. Next one, functionality and its significance. The number of bonding sites or reactive sites or functional groups present in a monomer is known as its functionality. Example, ethylene, the functionality, 2 bonding sites are due to the presence of 1 double bond in the monomer. Their ethylene is a 5 functional monomer. Then another one example, hexamethylene diamine. This monomer contains 2 functional groups can sit a 5 functional monomer. Third one, glycerol. This is the monomer contains 3 functional groups can sit a trifunctional monomer. It is one of the functionality and its applications. Next one, it got significance. 5 functional monomers. 5 functional monomers is a functionality of the monomer that is mainly from linear or straight chain polymer. Each monomeric unit in the linear chain is linked by strong covalent bonds, that is primary bonds, but the different chains are held together by weak van der Waals force of attraction, which is secondary bonds. Therefore, there is no restriction to movement of one chain over another. These type of polymers are soft and flexible and possess less strength, low heat resistance, These are soluble in organic solvents. Mixed functional monomers. This is called when a trifunctional monomer, that is functionality of the monomer is 3. It is a mixed functional monomer. Is mixed in the small amount with a bifunctional monomer. They from branched chain polymer. The movement of the polymer chain is branched polymer is more restricted than that of straight chain polymer. Polyfunctional monomers. This is nothing but polyfunctional monomers from cross-linked polymer, 3-dimensional network polymer. All the monomers in the polymer are connected to each other by strong covalent bonds. Therefore, the movement of the polymer chain is totally restricted. This type of polymers are hard and brittle and possess very high strength and heat resistance. They are insoluble in almost all organic solvents. Classification of polymers. Next one, these are the two types of polymers. Based on the source of polymers are broadly classified into two types. First one, natural polymers. Second one, synthetic polymers. Natural polymers of inorganic polymers of organic polymers. Synthetic polymers of inorganic polymers and organic polymer. Natural from inorganic examples, clay is a silicates. Organic example of proteins, polypeptide, RNA, DNA, cellulose. Synthetic polymers of inorganic silicones. Organic polymers of BE, BP, polyurethane, polyxray. Next one, natural polymers. These are the polymers are obtained from natural. That is called plants and animals are called natural polymers. Examples of natural polymers: starch, cellulose, protein, nucleic acids, natural rubber. First one, go to the starch. It is the polymer of glucose. It is a chief food reserves of plants. Next one, cellulose. It is also a polymer of glucose. It is a chief structural material of the plants. Both starch and cellulose are produced by plants during photosynthesis. Third one, natural polymers of protein. These are the polymers of alpha amino acids. They have generally 20 to 100 alpha amino acids are joined together in a highly organized arrangement. These are building block of animals. Fourth one, nucleic acid. These are the polymers of various nucleotides. RNA and DNA are common nucleotides. Fifth one, natural rubber. That is called isoprene reacted with the polymerations to form polyisoprene. This is one of the natural rubber. It is a polymer of unsaturated hydrocarbon 2-methyl 1,3 butadiene called isoprene. It is obtained from the latex rubber of trees. Synthetic polymers. The polymers which are prepared in the laboratories are called synthetic polymers. These are also called man-made polymers. Example, PVC, polyethylene, nylon, Teflon, bakelite, terylene, etc. Next one, types of synthetic polymers. These are the three types of synthetic polymers: organic polymer, heterochain polymers, inorganic polymers. First one, organic polymers. These are the polymers containing hydrogen, oxygen, nitrogen, sulfur and halogen atoms apart from carbon atoms. Examples of polyethylene, polyvinyl alcohol, PVC, epoxy polymers, polyurethane. Next one, heterochain polymers. These are the polymers are composed of carbon atoms and heteroatoms like nitrogen, sulfur and oxygen. The main chain consists of carbon atoms and whose sides of groups contains heteroatoms linked directly to the carbon atoms in the chain. Example, polyesters, polyamides. Inorganic polymers. That is called, these are the polymers containing no carbon atoms. The chains of the polymers are composed of different atoms joined by chemical bonds. Example, polysiloxanes, polyphosphoric acid. Thank you for everyone. Next topic, types of polymerization. That is called additional polymerization, condensation polymerization, copolymerization. Preparation, properties and applications of thermosetting plastics, epoxy resins and bakelite. Preparation properties and applications of thermoplastics, PVC, PTFFE and PMMA, rubber, compounding of plastics, blow molding, injection, extraction. Types of polymerization. Polymerization reactions may be carried out by any one of the following methods: addition or chain growth polymerization. Condensations are step-wise polymerization. Third one, copolymerization. First one, additions are chain growth polymerization. It is a reaction that yields a polymer which is an extract multiple of the original monomeric molecule. The original monomeric molecule usually contains one or more double bonds. In this addition polymerization, there is no eliminations of molecule. Example, ethylene reacted with heat and pressures of catalysis to formed by polyethylene. Second one, polyvinyl chloride formed. That vinyl chloride reacted with the heat and pressure and catalysis to form polyvinyl chloride. Third one, acrylonitrile reacted with the heat and pressure and presence of catalysis to form polyacrylonitrile. This is one of the additions of chain growth polymerization. Second one, condensations are step-wise polymerization. It is nothing but the reactions simple polar groups containing monomers with the formations of polymer and eliminations of small molecule like water, HCl, etc. Examples, hexamethyl diamine and reacted with the adipic acid to form nylon 6,6. It is one of the polyamide. Hexamethyl diamine and adipic acid condense to form a polymer of nylon 6,6 polyamide. Second one, alpha amino carboic acid reacted with it to form nylon 6. The polymerizations of alpha amino acid to form a nylon 6. In some cases, condensations of polymerization take place without the eliminations of small molecule like water, HCl and etc. but by just the opening of cyclic compounds. Third one, copolymerization. This is nothing but it is a joint polymerization in which two or more different monomers combine to give a polymer. High molecular weight polymers obtained by copolymerization are called copolymers. Copolymerization is mainly carried out to vary the properties of polymers such as hardness, strength, rigidity, heat resistance, etc. There is a copolymerization examples of butadiene reacted with styrene compound to copolymerate with to final product polybutadiene co-styrene or styrene butadiene or rubber SBR. Second one, examples of copolymerization, vinyl chloride reacted with vinyl acetate to form polyvinyl chloride of co-vinyl acetates. It is the copolymerization example. Next one, difference between addition polymerization and condensation polymerization. Next, that is called chain polymerization or stepwise polymerization. First point, the monomers must have at least one multiple bonds. Example, acetylene CH triple bond CH. The condensation polymerizations of the monomers must have at least two different functional groups. Examples of 6-amino hexanoic acid. It is H2N CH2 thrice 5 COOH. It is a NH2 one amino group of functional groups, another one COOH acid functional groups. Second point, monomers add to and to give a polymer and no other byproduct is formed in addition polymerization. That condensation polymerize condense to give a polymer and byproducts such as H2O, CH3OH are formed. Third one, number of monomeric units decreases steadily throughout the reaction. The condensation polymer monomers disappear at the earliest stage of reactions. Fourth point, the molecular weight of the polymer is an integral multiple of molecular weight of monomer. That side, condensation polymerization, molecular weight of the polymer need not be an integral multiple of monomer. Fifth one, high molecular weight polymer is formed at once. Molecular weight of the polymer rise steadily throughout the reaction. Sixth one, longer reaction times give a higher yield but have a little effect on molecular weight. The condensation polymerization, longer reaction times are essential to obtain high molecular weight. Seventh one, thermoplastics are produced in addition polymerization. Thermosetting plastics are produced in condensation polymerization. Example, polyethylene polyvinyl chloride. This is the condensation polymerization examples of bakelite nylon 6. The addition polymerization, one of the homochain polymerase obtained. Condensation polymerization is one of the heterochain polymerase obtained. Next one, go to the plastics. Plastics are high molecular weight organic materials that can be molded into any desired shape by the applications of heat and pressure in the presence of catalyst. Originally, plastics were discovered and then developed based on trial and error method. The present time is sometimes referred as plastic age because the use of polymeric material is percolated in large variety of applications. This rapid growth has taken place only in the last 50 years. It was man decided to develop plastics for engineering application to replace glass, metal, ceramic, wood and other materials of constructions. Since plastics possess of the following advantages, they have wider applications. Advantages of plastics over their material. First point, they are light in weight. They possess low melting point. Third one, they can be easily molded and have excellent finishing. They possess very good strength and toughness. Fifth one, they possess good soak absorption capacity. Sixth one, they are corrosion resistant and chemically inert. Seventh one, they have low coefficients of thermal expansion and possess good thermal and electrical insulating property. Eighth one, they are very good water resistant and possess good adhesiveness. Disadvantages of plastics, they are highly soft, they undergo empirical and low temperature, they undergo deformations of under load, they possess low heat resistance and poor ductility of. Fifth one, compressibility of is high. Sixth one, they undergo degradations of upon exposure to heat and UV radiation. Seventh one, they are non-biodegradable. Next topic of classifications of polymers. It is two types of plastics, thermoplastics, thermosetting plastics. This is based on structure of type of resins used for the manufacture of plastics. Plastics are classified into two ways. First one, thermoplastic plastics. Second one, thermosetting plastics. Thermoplastics examples, polyethylene, polyvinyl chloride, polystyrene, PAN. Thermosetting plastics, bakelite, polyester, urea formaldehyde and epoxy resin. First one, resin. Resin is a basic binding material present in plastics which undergoes polymerization reaction during molding. Second one, thermosetting resins. Thermosettings are prepared by addition polymerization. They are straight chain or slightly branched polymers and various chains are held together by weak van der Waals force of attraction. Thermoplastics can be softened on heating and hardened on cooling. They are generally soluble in organic solvents. Examples, polyethylene, polyvinyl chloride. Thermosetting resins are thermosets. Thermosetting plastics are prepared by condensation polymerization. Various polymer chains are held together by strong covalent bonds called cross-links. Thermosetting plastics had hardened and heating, and once hardened they cannot be softened again. They are almost insoluble in organic solvents. Examples of bakelite, polyester. Difference between thermoplastic resins and thermosetting resin. Thermoplastic resins, they are formed by additional polymerization. Thermosetting resins, they are formed by condensation polymerization. Second point, the thermosetting process consists of linear long chain polymers. Thermosetting resins, they consist of three-dimensional network structure. Thermoplastic resins are the polymer chains are held together by weak van der Waals forces. All the polymer chains are linked by strong covalent bonds. They are weak, soft and less brittle. They are strong, hard and more brittle. They soften on heating and harden on cooling. They do not soften on heating. They can be remolded. They cannot be remolded. They have low molecular weight. They have high molecular weight. They are soluble in organic solvents. They are insoluble in organic solvents. The resin is synonymous with plastics. Resin is non-synonymous with plastics. Examples of thermoplastic resins: polyethylene, PVC, etc. This is the thermosetting examples of bakelite, unformaldehyde, urea formaldehyde resins, etc. I go to the next topic of epoxy resins or epoxide polymers. These are the cross-linked thermosetting resins. They are polyethers because the monomeric units in the polymer have ether type of structure ROR. The epoxy resin preparation, biphenyl reacted with epichlorohydrin to formed by the epoxy resins. It's one of the below an example. Next one, the reactive epoxides and hydroxyls could give three-dimensional cross-link structure. The value of N ranges from 1 to 20. The product obtained is treated with alkali to get an epoxide. This is one of the properties due to the presence of stable ether linkage. Epoxy resin possess high chemical resistance to water, acids, alkalis, various solvents and other chemicals. Second property is they are flexible, tough and possess very good heat resistant property. Because of the polar nature of the molecules, they possess excellent adhesion quality. Uses: epoxy resins are used as surface coatings, adhesive like Erode, glass fiber, reinforced plastics. These are applied over cotton, rayon and bleached fabrics to impart crash resistance and shrinkage control. Third one, these are also used as limiting materials than electrical equipments. Molds and made from epoxy resins are employed for the production components for anti-grafts of automobiles.